The buzzword today is biotechnology, which holds the key to economic progress and enrichment of human life. In the midst of all this stands out an exceptional lady who has carved a niche for herself in a fast expanding area of molecular biology in one of India's leading biotech labs. Let us unravel the mystery of this successful lady. After the industrial and the IT booms, India is on the threshold of a third technological revolution, which is biotechnology. In what could be the next wave for India, the Indian biotechnological sector is all set to create 1 million jobs for scientists and engineers over the next 5 years. The estimated business is supposed to be in the tune of $9 billion. One lady who is very fortunate to be in the right place at the right time is Dr. Revati Chaganti. A molecular biologist by training, she is presently the only women group leader at Shanta Biotechnics Private Limited. Dr. Revati was an imperceptible architect of the first genetically engineered hepatitis B vaccine. She also took an active part in the development of the lab right from its inception to its present-day pristine white, state-of-the-art facility. Shanta Biotech remotely nestles in Medchil, which is a sleepy sylvan backwater 40 kilometers from Hyderabad.
Soon after completing my PhD from CCMB, one of my close associates who was also associated with Shanta Biotechnics was interested that I should work with them, basically to evaluate yeast and E. coli systems for expressing interferon alpha and to identify the best system. During that time, active research was going on hepatitis B vaccine development. Therefore, I actively participated in the development of hepatitis B vaccine as well, and that is now known as Shanvac B.
Biotechnology has emerged as an amazing innovation of our times. Never has humanity witnessed such a paradigm shift and transformation. Hybridomer technology involves human monoclonal antibodies, where one type of cell only synthesizes one type of antibody. This technology is widely being used in the treatment of cancers. Dr. Revati's second unique achievement at Shanta Biotech is the development of a cancer drug, interferon alpha or Shanferon, now available in the market, which until recently was imported at a formidable cost. She is also currently doing research work for cancers like myeloid leukemia and AIDS-related Kaposi sarcoma.
The Shanferon or interferon alpha is a cytokine which is made normally in healthy human beings. It is an anti-proliferative molecule and an antiviral molecule. Because of these properties, it is used for clearing viral infections like hepatitis C or hepatitis B. And because of its anti-proliferative properties, it is used in managing several cancers.
After completing her BSc from Koti Women's College, Hyderabad in 1978, Revati worked at the Central Forensic Science Labs for 4 years and later joined CCMB in 1983. While working there, she did her MSc from Annamalai University. Subsequently, in 1996, she completed her PhD from CCMB.
My first career move itself was in the science. Earlier, I worked in Central Forensic Science Laboratories, where I was working in the chemistry and physics departments. I worked for 5 years, but I found that work was getting monotonous, during which time I came across this job in CCMB. I worked for about 17 years there. I liked biology. Basically, I had developed lots of skills in molecular biology and recombinant DNA work. So I liked it, and so I kind of settled in that area.
Dr. Revati formally joined Shanta in the year 1999 as a scientist taking care of R&D activities involving molecular biology. She mostly concentrated on genetically modifying clones to harbor a gene coding for expressing selective proteins for therapeutic use.
To select the final clone expressing the protein of our interest, several colonies are grown individually in culture flasks, and the proteins are analyzed in this gel, which is known as polyacrylamide gel electrophoresis. Depending on the protein expression profile, one of the clones which is expressing highest amounts of the protein is selected.
The final clone is multiplied by culturing in large volumes and stored at -70 degrees centigrade in a cell bank indefinitely for any length of time. The central part of biotechnology today is the master molecule or DNA. It can be cut and rejoined to give new combinations of genetic material. For gene expression, the DNA must be introduced into an appropriate cell. Recombinant DNA technology is providing powerful new tools for biotechnology, particularly for the application in the biopharmaceutical industry.
Biopharmaceuticals are recombinant DNA based products. These could be vaccines or therapeutics or antibodies, monoclonal antibodies. In the case of vaccines, you take the gene responsible for giving immunity. It will be a viral gene which will code for a viral antigen, and therapeutic molecules are from human body, which are normally present in healthy people, and in the disease state, because of their lack, people are unable to combat certain infections and diseases. By providing externally, it takes care of health management. Some of these molecules are GM-CSF, that is granulocyte macrophage colony stimulating factor, GCSF, and erythropoietin, insulin. There are many more such therapeutic molecules which are used to treat many diseases.
The brain behind the vision that is now Shanta Biotechniques is the Managing Director, Mr. K. Varaprasad Reddy. He is very appreciative of her achievements.
Dr. Revati joined us around 5-6 years back, and we are very happy with her contribution. And I have to say that she did an excellent work in science. She has been very innovative in one or two areas of her work. She deserves a national award. Hope that day will come, but what from Shanta side we can say is, we respect her as a great scientist, and of course she has to be a good human being also, because she could groom an excellent team with her who are working with her.
As a group leader, I participate in the selection of projects to be worked out, and also collaborations with other academic labs.
Almost all the biotech products in India's 12 crore biotech market have been indigenous versions of existing products in the West. Will there be a change in the scenario by coming up with novel products in future?
So far, all the companies which are working in the biopharmaceutical industry have been trying to make what are kind of generic products. Once the patent regimen comes into enforcement, people have to work towards development of novel products. Therefore, it is going to be little tough for us to compete. But if we are judicious and select carefully our problems which are relevant to our society, like malaria or tuberculosis or childhood diseases like Japanese encephalitis, I think we have lot of scope to come up with novel therapeutics and vaccines. These are our problems, they are not the problems of the West. We need to address them and then come up with appropriate treatments for that.
Biotechnology is in fact a very old science. preparation of alcoholic beverages such as beer and wine, foods like bread, cheese, buttermilk, vinegar, soya sauce, etc. is all biotechnology. The traditional form of biotechnology took an industrial form when in 1863 Louis Pasteur demonstrated that the active agents of fermentation are living microbes. Later, the knowledge of microbiology and biochemistry led to the commercial production of the wonder drug penicillin by Alexander Fleming during the Second World War. Subsequently, industrial biotechnology has exploited microorganisms to produce large quantities of amino acids, organic acids, enzymes, and antibodies. Biotechnology now involves different stages for the development of new healthcare products, from concept evaluation to regulation and patenting. Scientists are now trying to tailor spirulina, the blue-green alga, to produce biopesticides and biofertilizers. New techniques for dehydration and preservation of fruits and vegetables, genetic fruit ripening, and genetically engineered new fruit varieties are in the making. What makes the future of biotechnology so promising is the excitement of innovation derived from the sophistication of modern biological sciences. It includes the introduction of new genes into plants and animals to create transgenic organisms. But the faster the pace of technological change, more acute is the ethical dilemma.
In the kind of work which we are doing, that is recombinant DNA based therapeutics, ethical issues are largely taken care of, and we are not doing anything new. They are all tested methods and the products are tested, everything is worked out. But if you talk about human cloning and larger issues like expressing proteins in plants, introducing new genes into plants, there is a huge debate going on worldwide about whether how ethical this kind of practice is. I think depending on the context and the need for such technologies, one cannot really have a all-encompassing kind of an policy. The policies need to be changing depending on the requirement and the context.
There being plenty of opportunities for young girls in the highly competitive field of biotechnology, Dr. Revati has a few words of advice.
Particularly industrial biotechnology is a fast growing and emerging field in India. It's challenging, at the same time highly demanding. Women who are willing to put in lot of hard work and dedication will find very good opportunities and growth in this area.
Revati also collaborates with other research organizations for coming out with novel biotech products.
I have been collaborating actively with a plant biology group in BARC, Bombay, and we are trying to express hepatitis B vaccine in plants, and we have been able to do something novel, and we have published our work in a good journal, and we are also working towards expressing the antigen in bananas.
Dr. Revati's invisible efforts become visible when she puts the smile back on the lips of people suffering from hopeless ailments.
I have been extremely satisfied with my work. I wanted very much to be in an area where my work had impact on the lives of people immediately, and that way I have been able to work towards bringing out two products which are of immense value to the society.
Though Dr. Revati comes across as a very modest person, despite her spectacular achievements at Shanta Biotech, yet her rigorous research has brought a revolution in the indigenous production of drugs and vaccines, which are now easily available for the common man. Biotechnology requires more women scientists like Dr. Revati to make all the difference to health and society at large.